What if I told you that one sentence you did throughout secondary school is actually incomplete? You probably heard it this many times as it only works in water.
What?
It sounds correct, but today I'm going to show you a chemical reaction that completely destroys that idea. No water, no solution, no beaker full of liquid, yet an acid reacts perfectly with a base. How is that possible? Stay with me, because by the end of this lesson, you will never confuse acid and bases again.
Hey y'all, come look at this.
If you are preparing for examination, O-level exam, or exam at your undergraduate level, you're exactly where you need to be. Today's lesson is one of the most important concepts in chemistry, the Brønsted-Lowry Theory of acid and bases. Let's solve the mystery. Look carefully at this particular reaction. NH3 gas plus HCl gas to give you NH4Cl solid. What did you notice? No water, nothing is dissolved, yet ammonia reacts immediately with hydrogen chloride to form ammonium. If the Arrhenius theory says acid produces hydrogen ion in water, then how did this reaction happen? Scientists ask exactly the same question over 100 years ago. It was 1923. Chemists around the world were discovering reactions that simply didn't fit the Arrhenius definition. According to Arrhenius, an acid had to produce hydrogen ions in water. The base also had to produce hydroxide and OH minus ion in water, but many reactions were occurring where there wasn't any water at all. Something was missing. Then, two scientists working independently reached the same conclusion: Johannes Brønsted and Thomas Lowry. They proposed an entirely new way of thinking. Instead of asking, is water present, they asked a much better question: who gives away the proton? That single idea changed acid-base chemistry. And forget complicated definition. Remember this forever. An acid is simply a proton donor, and a base is simply a proton acceptor. And that's it. The entire Brønsted-Lowry theory can be summarized in one sentence: acid gives, bases receive. Or even shorter, acid donates hydrogen ion, which we call proton. Bases accept hydrogen ion, which is also proton. And what is a proton? Now you may be wondering, what exactly is a proton? Hydrogen has only one proton inside its nucleus. When hydrogen loses its electron, what remains? Just the proton. That proton is represented as H+. So whenever friends say proton transfer, they simply mean the transfer of hydrogen ion from one substance to another. Let's look at this example where ammonia NH3 plus HCl hydrogen chloride gives ammonium chloride. This reaction is one of the most beautiful examples in chemistry. Let's slow everything down. Hydrogen chloride has an hydrogen atom attached to chlorine. Ammonia has a lone pair of electrons on nitrogen. Nitrogen sees the proton. It wants it. Hydrogen chloride lets go. Ammonia grabbed it. Instantly, ammonia becomes NH4 plus ammonium. Chlorine becomes chloride, Cl minus. The ions combine, forming ammonium chloride. So now answer this: who donates the proton? Hydrogen chloride. Therefore, HCl, which is hydrogen chloride, is the acid. Who accepted the proton? Ammonia. Therefore, NH3, which is the ammonia, is the base. Notice something fascinating. There wasn't any water, yet the reaction worked perfectly. That is why the Brønsted-Lowry theory is much broader than the Arrhenius theory of acid and base. What about this reaction? HCl plus H2O equals H3O plus Cl minus. This example happens in water. Again, watch the proton. Ignore everything else. Hydrogen chloride gives away proton, that's H+. Water accepts H+, that's the proton. Water becomes H3O plus hydronium ion, that's H3O+. Once again, HCl donated, water accepted. Exactly the same principle. The only difference is that this time, water is the base. Think like a chemist. Here is the secret that top students understand. Don't memorize the equations. Follow the proton. Ask yourself only two questions. Who lost the proton? plastic plus, and who gains H plus the proton? Once you answer those questions, you automatically know. Why is the Brønsted-Lowry theory considered an improvement? Because it explains far more reaction. It works in water, it works without water, it works when you have your acid in gas in gaseous form, even in many chemical systems. The Arrhenius theory is still useful, mind you, especially in introductory chemistry, but the Brønsted-Lowry theory gives us a much deeper understanding. Please listen carefully. One of the most common examination questions is, according to Brønsted-Lowry, an acid is, many students rush to choose produces H3O plus. That is not the Brønsted-Lowry definition. Correct answer is a proton donor. An acid is a proton donor. Read that again. An acid is a proton donor. Whenever you see Brønsted-Lowry, think donate hydrogen ion. Whenever you see base, think accept proton. That's H plus. I have a memory trick you will never forget. Imagine two friends. One friend loves giving gifts. The other friend loves receiving gifts. The giver is the acid. The receiver is the base. Acid gives, base receives. Simple. Every reaction to come is now it's your turn. Look at this equation. Na3 plus HCl equals NH4Cl. Without looking back, tell me in the comments which substance is the Brønsted-Lowry base and why. I'll be reading your answer. You might think every acid must contain hydrogen, but what if I told you there are substances that behave as acid without donating hydrogen ion at all? Impossible, not at all. That's exactly what the Lewis theory explains, and trust me, it will completely change the way you think about chemical bonding. And that's our next lesson. If this lesson made chemistry easier to understand, don't keep it to yourself. Like this video, share with a friend that needs it. Subscribe for more chemistry lessons explained in the simplest way possible. Follow us for more educational content. Remember, chemistry is not difficult. It only needs to be explained the right way. I see you in the next lesson. My name is Omotola Fayomi.